Good day guys, today we're going to solve this problem using parallelogram law. Let's read the problem. If the resultant force acting on the support is to be 1,200 pounds directed horizontally to the right, determine the force F in rope A and the corresponding angle theta. So what is asked in the problem guys is the value for our theta and the magnitude for our force A. So let's draw these forces guys on our x and y axis. So this is now our forces guys on x and y axis. And let's remember guys that in the question it states that the resultant force acting on the support is to be 1,200 pounds directed horizontally to the right. What that means guys is that our resultant force must be along on our x axis since it is directed horizontally to the right. So it will look like this guys. So this is our resultant force, that is 1,200 pounds. Now that we have the resultant line guys, let's draw the parallel line so that we can form the parallelogram. So from the tip of our force A guys, let's draw a parallel line of our force B. So since this is parallel to our force B guys, so this is also 900 pounds. And now from the tip of our force B, let's draw a parallel line of our force A. So since this is parallel to our force A guys, the magnitude of our force A into this area guys is equal. So that is our missing value. Now that we have the parallelogram guys, let us now identify the missing interior angles of our parallelogram. So if we try to look at this guys, on this area right here, so this is 90 degrees, a total of 90 degrees guys. So in finding the angle right here guys, we'll just have to subtract. So 90 minus 60, that is 30 degrees. So if we try to look at our parallelogram guys, we can actually identify the angle right here guys, since on that angle guys, this angle right here or this side right here guys is an alternate interior angle of this side, so they are equal. So that means guys is on this angle right here, that is also 30 degrees. And our resultant force or our resultant line guys divided our parallelogram into two congruent triangles. So this triangle right here and on the bottom guys is equal. Now guys, in finding the value of the magnitude of our force A guys, let us draw one of the triangle guys so that we can apply the law of sine or the law of cosine. So let's draw this top triangle guys. So this is now our triangle guys, so let's copy the values. On this side right here, this is the force B, or parallel to our force B, this is 900 pounds. And this is our resultant force right here, which is 1,200 pounds. This angle right here is 30 degrees. And this is our theta, which is our missing. And this line right here is our force A, which is also missing. Now guys, in finding the value of the missing part of our triangle guys, first we can use the law of cosine to determine the value of our force A. So force A squared is equals to 900 squared plus 1,200 squared minus 2 multiplied by 900 and 1,200 cosine the opposite guys angle of our force A, that is 30 degrees. And let's square root guys both sides so that we can cancel the squared of our force A. So force A is equals to 615.94 pounds. So this is the value of the magnitude of our force A. Now guys, let's determine the value of our theta. Since guys, we already have many values of our triangles, now we can use the law of sine. So in finding our theta, guys, we will now be using the law of sine. So sine theta over its opposite side, guys, that is 900 pounds. 900 is equals to sine 30, and its opposite side is the magnitude of our FA, and that is 615.94 pounds. So now we can get the value of our theta is equals to arc sine 900 times sine 30 over 615.94. So the value of our theta is equals to 46.94 degrees. And that's how, guys, we can get the value of our theta.